Welcome to the Cycle World Podcast. I'm Mark Hoyer. I'm with Kevin Cameron. Our topic this week is Suzuki and Grand Prix road racing. And I like this topic because, well, mostly because I know Kevin Schwantz and I watched him race at Laguna Seca in the late 80s and early 90s, or right in 1990. And I watched the Pepsi Suzuki come off turn 5 at Laguna, and he was doing a crossed-up wheelie, spinning the back tire, with the bike wobbling around and then hurtling toward 5 and shooting up the hill. Peak two-stroke era for me, obviously, because I was there.
That'll do it.
And Laguna was pretty cool because they'd come over what they call turn 1, the hill, and at the end of the session for practice and qualifying and plug chop. And so they'd whiz over the hill, and then the bike would shut off and you'd hear the fairings flutter. And then they would break at the end, just at the entry to turn 2. And then the mechanics would walk over, and I'd watch Kel Carruthers, who I had yet to meet, walking down to meet Eddie Lawson, and Kevin would be walking by, and everybody like, Kevin, a skinny little kid. It was neat times, but they have, they have a pretty rich history. Of course, we know Barry Sheene, Kenny Jr., and then they're out. So you were more there than me. Why don't you kick us off?
Well, okay. I think what's periodically valuable to do is to recall that the Japanese manufacturers had to start from zero. They might have an RT 125 DKW from either World War II era, or they produced a bunch of them after the war. But that was the starting point for so much two-stroke activity. It was a simple one-cylinder, 3-speed piston port, the bare minimum transportation, 4.5 horsepower. And you weren't going to learn a lot about two-stroke engineering from that, except that here's one that works. And if you want to make these, fill your boots. So Suzuki, of course, was a loom manufacturer. And there are some gloomy, dark pictures, very much like modern television, with these gloomy, dark machines in the background. That was their business. When the war ended, they thought, well, of course, we'll have to make clip-on engines for bicycles. Yamaha had made propellers during the war. All of their machine tools were seized and their use denied for a period of years by whatever control commission. Honda made piston rings. Later, they would make clip-on bicycle engines. So this little engine made 2 foot-pounds of torque.
Don't I make 2 foot-pounds of torque with pedals? I don't know. Maybe, probably not.
So they were thinking to themselves about competition. And it seems that this idea was quite common in Japan in motorcycle circles in the early 1950s. Namely, we don't know what the Europeans know. And if we don't learn it fast, they will come here and take our motorcycle market, which we frankly would like to have for ourselves. So racing is the ruthless provider of truth in motorcycling. And that's a great thing. You can't talk your way out of a DNF. Well, we actually won, you see, except all this other stuff happened. So they decided they were going to enter the lowly class in a 1953 all Japanese racing class. And they were very pleased with themselves to have finished this course, I don't know the length, in under an hour, and were close behind the slowest of the much bigger motorcycles. This encouraged them. Then they decided they were going to soup up their Coleda single cylinder 125 and race that. And the pistons rose like cakes. The big end bearings melted. And all these things happened that are the basis of the old saying, bring last year's bike to this year's Daytona, because you know that one works. And if it doesn't, Daytona will find it out. So they tried racing their hotted up production bike, and they soon, this is not working. We're not doing this. So they made Coleda RB, which was made for racing, also a 125 single, and they started solving the problems that they ran into. Now, the first time that I looked at a Suzuki connecting rod, sometime in the late 60s, I thought, oh, look, the big end is really small. I had the same reaction to Bultaco rods. Well, what they discovered is what Daimler-Benz discovered in 1940 with their all roller bearing V12 aircraft engine. If you rev the thing up just even a little bit, may cause roller skidding. Why? Because as the crank pin revolves and the bearing on it is turning nominally at the crankshaft speed, there's also added and subtracted the back and forth swing of the connecting rod. And that causes the speed of the big end bearing to vary by plus and minus 25%, 2 times every revolution. That's a lot of speeding up and slowing down.
Well, so is there not also, say, centrifugal force? Wouldn't it tend to? Wouldn't it?
Well, it's flinging the
bearings. The bearings would sort of work against the cage. I mean, there's a lot happening.
Well, originally, for example, Vincent's had crowded rollers in their big end, and SKF said no more than 5,800 RPM on this thing, except for short moments. But you're right, all those rollers are centrifuged to the outside, and the weight of several rollers is bearing on the roller at the apex, which is kind of getting all squashed. That's the reason to have a cage.
Kevin squished his face, Spotifyers. He smashed it together. It was awesome.
So the cage keeps the rollers from banging into each other. But this speeding up and slowing down, Suzuki found, making the bearing larger and stronger makes it fail sooner. Why don't we go the other way? So they made the crank pin smaller. They made the rod big end smaller. Results better. And so that was the early secret to successful connecting rod big end bearings, was to make the crank pins as small as it could be and still have adequate strength.
First time I went into an RD 350, I was very surprised at the air quote big end of the crank pins. You know, like the connecting rod. I was like, huh.
Yeah. Well, there's the reason for it.
Intuition says we should make it huge.
Yes, and in fact, if you look in the bearing books, it tells you that the larger you make the rollers, the lower the stress that's produced under the surface, which ultimately causes cracking. And the cracks come wiggling, and they reach the surface, and usually at an angle, and a little piece of the edge of the crack breaks off into a flake. Is the flake large enough to stop a roller? If so, in the twinkling of an eye, all the rollers have become interleaved black pieces of sharp-edged steel. Now, I've seen this many times. We're changing the crankshaft this afternoon, so rally round.
Well, my RD was making choo choo sounds, and it was flaking. You know, it was making that kind
Yeah.
of
Oh, yeah.
because the bearings were going away, and all that flaking. You could see that flaking. It was not pretty.
Nope. So they soon found out how to make a racing bearing that would last a race, and they went and raced at the next, maybe it was 55. I think they missed in 57, and they raced against Yamaha's YA1, which was also a 125 single. Yamaha by that time had some race smarts. They'd been doing it a while, and they knew how to get the best out of their bike, and they cruised to an easy win. And the Suzuki guys went home all chagrined. Oh, our poor motorcycle is so inferior. But somehow, it went 77 miles an hour. It had the same top speed as the YA1, but it encountered vicissitudes. I'd like to see one sometime. Anyway,
A vicissitude.
yes, and put it in a strong box so that it can't get out. Anyway, by some accident, some professional meeting or what have you, Shunzo Suzuki and Mr. Soichiro Honda encountered one another, and Mr. Honda, with his wonderful toothy grin, seems to have clapped old Suzuki on the back and said, "Hey, your bike is pretty fast. You guys ought to race in Europe." And he might have been saying, "Good luck," inwardly, but this was encouraging. Yeah, maybe we should do that. And so they decided to send a team to the Isle of Man, and with tape measures and cameras and inclinometers, and they measured every turn. They measured pavement texture. They were thorough. And they came back with voluminous reports. I don't know how they would help anyone, but at least they knew how far around it was with 37 and
What a place to
miles.
start, though. I mean,
whoa!
How about a 10 laps on a 2-mile track? Let's start there.
Yeah.
You know,
Right.
Not the TT.
So they had a lot of trouble, and at one point they stopped for a while, but they were going racing in Europe, and they were having indifferent results. Now, it's important to know that there are many secrets in a Grand Prix paddock, but they're not well kept because these people are lonely. They're away from home for months at a time, sleeping two up in hotels with other persons who may snore loudly or emit other noises. And they talk to each other. They have friends, they talk. And I learned about this from that man of few words, Ginger Malloy, a New Zealand racer who finished second in 500 Grand Prix racing to Giacomo Agostini in 1970, himself riding an over-the-counter 500 Kawasaki H1R. And he could lay hands on the most exotic things. These cylinders, which are most secret, would travel across Europe to northern Spain, where they would vacation in the sun for perhaps a week, and then they would reappear in inventory in whoever's truck it was, big factory transporter, big in those days, and no one the wiser. And there was also the question of who actually knows how to go racing. Because when you send engineers to a racetrack, most of them have no idea what are we supposed to do here. So that's why early Grand Prix race teams all had a European um, technical guy in charge of the team, because he knew how to get to the next race, for one thing. He knew how to get a carnet. He knew how to get through customs. Europe wasn't a common market in the 1950s. And these people also knew the ropes. So we've told you the story before about Kel Carruthers at Barry Sheene's shop sawing the whole steering head off of their Yamaha and then standing back. How does this look? Holding up the steering head. Little less. Okay, how about that? Yeah, that's better. Tack it there. Okay, I'll hold it. You tack it. And this kind of rough and ready stuff mystified the Japanese, because in their corporations there were procedures for everything. Perhaps those of you who work for organizations have encountered them. And they needed these practical people. Well, Suzuki had their eye on Ernst Degner, who was working for MZ, lately IFA, an East German firm that had inherited and then built upon the work of the now revered Daniel Zimmerman, who won a bunch of championships in East Germany. He was one of those people, when the war ended, he just got busy and became reasonably prosperous. And then one day along comes the Stasi and they say, you will hand over all notebooks, all parts, all complete machines, test results, and you will not work on motorcycles ever again. Sign here. The Stasi could be persuasive. So he went off to race outboards. And his concept of a disc valve, 125 single, quickly in the hands of MZ, who had more resources than an individual craftsman. They soon had the thing making 20 horsepower, which was as good as any of the four-strokes at that point. So Degner would be quite a good catch. He would know a number of secrets. He would know where to get things. And so the very famous escape of Degner and his family from East Germany has, I don't think there's a song, but there are certainly film and print versions. Very exciting Cold War stuff. But not everything that he brought to Suzuki was necessarily a gain. Suzuki had already discovered that the big problem of the two-stroke engine is that it fires twice as often. And it has, where a four-stroke has 540 degrees for the piston to cool before it fires again, the two-stroke has 250 degrees. So pistons get hot, they swell like cakes, they stick, or they break into crumblies, so that you take the exhaust pipe off and shake the piston out of there. Oh, those used to be wrist pin bosses. Oh, there's the fragments of the piston ring. So these people had to go through this business over and over and over again in order to come up with stuff that worked. And Degner was a considerable help, I'm sure, because he'd been doing it for a few years already. He knew the ropes. And Suzuki's original race team guys were, first of all, Masanao Shimizu, who was the chassis guy, and Takeharu Okano, the engine guy. And at a point in 1962, they hired Makoto Hase, who would later design the RG500, on which
Hey, right on.
Barry Sheene would win 2 world championships. And after Kenny Roberts got through winning his 3, later versions of the RG500 would win First in 81 with Marco Lucchinelli, the tire conservator, and then Franco Uncini, who was later MotoGP safety officer. So 2 more championships, 4 championships. Why did Suzuki decide that they should build a 500 class 2-stroke racer? Well, they looked at the results and they could see. I mentioned that in 1970, Ginger Malloy was second to Agostini. Now, who used to be second? Somebody on a Norton or a G50. Big singles that were last produced in 1962. A few were built the following year from parts. So no wonder that the FIM at one point said, do we really need the 500 class? We only have one constructor. But that situation changed. Suzuki also knew that they had been supplying parts and equipment to people who were running versions of the 500 twin Suzuki called Titan, spelled Tight apostrophe UN. And because, of course, the frightening thing is the bigger the piston, the more area it has to gather heat.
And the longer it takes to get it out.
Yes, sir.
The heat path is to the center of the piston where you usually find the hole.
Yes. It is no surprise that the first 2-stroke to win an FIM World Championship in road racing was a 50cc Suzuki RM62, I guess, which was ridden by Ernst Degner in 1962. And the thing had, 8 or 10 horsepower. And Honda wasted no time with the CR110 concept, and they soon made a twin. And Suzuki came back and won 2 more 50cc championships. And the Honda guys said, well, we've got to get serious here. We can't have this. This is shameful. And so the very young Shoichiro Iramadri was put on the job, and he sort of made a breakthrough, finding that it was better to reduce friction than to try to increase power, because they'd done all the souping up they could. And what they really needed to do was to get the enclosing walls of the crankcase away from the crankshaft and to shorten the pistons and, do all the friction reducing things. There was real power there. So they won the 50cc championship in 1965. All's well. But then they made a terrible discovery. It's cheaper for these 2-stroke idiots to come up with another horsepower, way cheaper than it is for us with the 4-stroke, because the 4-stroke makes increased power by increased RPM. Because the breathing, the cylinder filling, is something that's been worked on for half a century. And so revving it up is the best solution. With the 2-stroke at this point, people weren't really on the beam with exhaust pipes. They were making hundreds of them and testing them. And they would ultimately be able to fill the 2-stroke cylinder so that the energy expended in the stroke was equal to or greater than that of a 4-stroke by using the exhaust pipe as an acoustic supercharger. So the Suzuki guys said, well, we made a lot of pipes. We made 1,000 pipes during those few years of the 1960s and tested them one after another. And this is why I'm a bit skeptical when I see these advertisements for packages, software packages to design your perfect 2-stroke. I'm sure it gives a decent starting point, but there's nothing like the dyno to uncover all the little glitches that reality puts in our way, such as banana peels. So developing the two-stroke engine was an intense step-by-step process. So back to what Suzuki was looking at, they saw these two strokes that were finishing right behind Agostini, and they said, this is the opportunity of the century, because all we have to do, I mean, one guy won the championship, Kim Newcomb, with an outboard powerhead. The thing was fast. And so all we have to do is design a competent engine, making 100 horsepower, and we'll blow these guys down. So Makoto Hase makes a single-cylinder test engine. This is a good way, not have to grind 4 different cylinders and weld 4 different pipes. We'll work on our single cylinder 4 times more quickly. So they got 95 horsepower. They had been using the same basic transfer port arrangement that MZ was using, which everyone else therefore used. Oh, this is the secret. This is the key to the whole thing. It was actually lousy. It was just the best thing that they had. So Hase is looking at this thing. Not only does it not make 100 horsepower, which we need, but its power is so narrow, we can't make it work with a 6-speed gearbox that is now required by the class. See, when the classic era of Grand Prix racing ended in 1967, the FIM said, now what? All these wonderful factory racing has entertained the daylights out of people for all these years. What are they going to ride? So they said, we've got to restrict this thing. First of all, no more 12-speed gearboxes with extra support bearings in the middle so that the shaft isn't going ga-ding-ga-doing. And some of those photos of the oyster on the half shell, the crankshafts, rows of them, little gears, it's marvelous Swiss watch precision. But imagine having to lug all that stuff around with your little motor. It needed to be simplified. So they made the 6-speed rule, and they also made a rule that said 4 cylinders maximum and 2 cylinders in 250 and 1 cylinder. But later on, they made a 1-cylinder rule for the 125s. So Hase looks at this scavenge scheme, and I think that he got himself a copy of Paul Schweitzer's 1949 classic on scavenging of high-speed diesel engines. And I can't cite the page number, but the book is over there on the shelf, and it shows what's called Curtis scavenging. In Curtis scavenging, the transfer ports that are closest to the exhaust have a 0 roof angle. They come in at 90 degrees to the central axis. The second pair of transfer ports angles up at 30 degrees, and the third pair angles up at 45 degrees, and then there's a finger port or two in the back wall that's really pointed up at 60 degrees. So the roof angle increases as you move away from the exhaust port. And I think about Curtis scavenging every time I heat water in the electric kettle, because it has a ring of heat that causes rising bubbles that is very much like Curtis scavenging. It causes the material in the water kettle to circulate so that it heats very quickly. Anyway, they put this thing on the dyno, and it made 114 horsepower.
Oh, wow.
And it got better gas mileage, and it had broader power. So it was like those 5-cent nostrums that people were always talking about for your motorcycle. It says more power, better gas mileage, and a whole bunch of claims that just forget it, go
Well,
away.
that's the sounds like the raising of the pirate flag right there when the two-stroke pirates would take over.
Yeah, well, and of course, MV in Italy, MV Augusta, were fading out because the count had collapsed in a business meeting in 1971, and the remaining management somebody want this, or what are we?
Yeah.
We're not in the racing business. We're helicopter manufacturers, and so I think the last time a factory MV ran was 76 or 77. So Suzuki fields the RG500. It still has, it's a fairly narrow power band, but they compensated for it to a degree by timing the disc valve very much like those single cylinder YA6s that people used to ride. Kawasaki also made little Campus Cadet singles. Um, the disc opens at 120 and closes at 55 after top. And so it was a really a strange combination. It's this racing engine with all these transfer ports, beautiful shaped, lovely things, and with a Campus Cadet disc valve timing. So the thing ran, but it didn't shift. And there were different problems. They kept getting better results. And then by 76, Barry Sheene won the world championship. And then he won it again in 77. But Steve Baker was second on a Yamaha. Yamaha had been running an inline with these little dinky reed valves on it. The same part number as for the Child's 80cc motocrosser. Little 4-pedal thing. And Irv Kanemoto used to refer to that reed as the restriction because they put the same reed on the TZ750. It was made for an 80cc cylinder. Then they put it on a 125 cylinder, and finally they put it on the big cylinder. So it was a restriction. So in 77, what Yamaha did was they put separate cylinders on the inline engine, and they ran piston-controlled intake, and they were really big intakes. So the thing was more powerful, but not as powerful as the RG500. So then Kenny arrives, and at first they said, "Well, you're American, aren't you? Are you American?" "Yeah, I think so. We have our riders all scheduled here, but we'll give you some parts maybe, particularly if you get good results." He got good results. This was 1978. So then they gave him the full deal. An engine with variable exhaust port timing. It had these eyelids in the port which rotated, and the edge of the cutaway portion of this rotor functioned as an eyelid, and it broadened the power enough to more than make up for the lack of power in comparison with the RG. And Kenny was able, in an exciting season in 1978, to take the title from Barry Sheene. And so that appeared to be it for a while. Kenny had it covered. 78, 79, 80. In 81, Yamaha gave Kenny a disc valve. Can't beat him? Join him. We'll make our own RG500. It was difficult. Kel had to change all the port timings, Kel Carruthers. And Kenny didn't get real good results on it. And the tires didn't like it either. So guess what happens? In 1981, Marco Lucchinelli notices, as who could not at the time, these bias tires are junk. They're only good for about 10 laps. So he formulates a strategy. I'm going to let the fast guys wear out their tires, and I'm going to hang back just a little bit. I'm not going to push, I'm not going to play, and then they'll come back to me because I've seen it. And that's what happened. The fast guys' tires went off, and this was an irreversible change. This was the thing. There were people who would collect, who would beg or buy used takeoff tires from the teams. Oh, what a treasure. They would take it away. It was garbage because it had internally, chemically failed. So Lucchinelli was world champion on an RG500, making nearly 130 horsepower at this point because it was really easy to boost the power. And that's what Makoto Hase said. He said, we can improve the power very easily, but we choose instead to improve the handling. So they began to play games with long travel rear suspension. Then that took them to single shock, and that took them to linkages so that you could have any curve you wanted of suspension movement versus spring rate. And that was a revolution. That was a very powerful thing in Grand Prix racing, because prior to that, it was, well, we have rear suspension. It's a swing arm. We've got two shocks on there that have 3 inches of travel. That was standard. Don't question it. Just get on and race it. And as people have commented, the Honda factory racers, the conclusion was that suspension works best, which moves least.
Yeah.
Constant geometry.
Yeah, that was the Alan Girdler quote about, it's what he said about suspension in the 1970s. It was the best way to make it work was to not let it.
Not let it. So at this point, Cook Nelson, who was the next to last editor of the beloved but gone forever Cycle magazine, somebody from Suzuki got in touch with him and said, we want to bring you to Japan. We want you to ride the RG500. We're very proud of it. It's been quite successful. We think that you'll find it interesting. Well, at the time, Nelson had been riding Ducatis, 60-inch wheelbase, 31 degree steering head angle, and 12 feet of trail.
Yeah,
and he was used to motorcycles that cornered as if on rails, as locomotives are. You can't steer a locomotive once you're in the turn. You can't say, oh, I'm going to take the inside line. You're committed. He came back from Japan sort of shaking his head. He said, on that RG, he said, I only had to look and the motorcycle would go there. He said, I suspected it of reading my mind. Well, what had happened was that suspension had left the beautiful Ducati that Nelson and the late Phil Schilling were building behind. And they would, of course, do their best to make up the distance. But after Uncini won the 1982 championship, guess what happened next? Everyone with the disc valve motor was furiously trying to make more power. Here came Honda in 82 with Freddie Spencer. How much power was he worth? And a little 3-cylinder 500, basically 3 motocross singles on a common crankcase, making 108 horsepower. Well, this was a big shakeup because at Spa, the place you expect to win because you've got a powerful engine, you can just sing the high, sweet song of horsepower past all the others. This little putt-putt managed to win. And of course, it did it in Lucchinelli style. Let the others come back to you.
Hmm.
And so this meant an entirely new style of Grand Prix motorcycle had to come into being. And it would take Suzuki quite a while because they tried lightening their bike. They tried making the engine more compact. Meanwhile, in '84, Yamaha decided we're done with disc valve. We're going to put those large area reed valves like Honda's and build a V4 with 2 crankshafts. And Eddie Lawson used that thing to win the world championship in '84 after Freddie had won it in '83 on the little putt-putt 3-cylinder, which was not harmful to tires. In fact, so little harm could it do to tires that when Freddie complained about some big sweeper at Silverstone, he said, I can't use the throttle to steer. Irv said, just do the turning at the point where the engine's making peak torque. So he went round, as people used to say, round a thruppenny bit, which was a piece of English coinage that had flat surfaces all the way around, connected by little corners. That's the way he went round the corners because he didn't have the power to steer with the throttle. And this was a completely new kind of motorcycle. Suzuki built a V4 in '87 that had large area reeds, and they got with the program. But I think it was hard for them. When you visit Suzuki, you see that they haven't spent a lot of money making their buildings look like the United Nations. They look functional. They don't have 800 engineers to put on a project.
Well, I'll tell you, I visited Suzuki's museum. It was for the GSX-R 750 launch. We went to Ryuyo, which is their test track, their famous test track. It has 2 very long straightaways, and it has a 5th gear, I guess, chicane. I don't know. So it was really something.
Chicane. Yes.
Yeah, you would hit the rev limiter going through that because you were leaning it enough that the ratio of the tire changed. You'd hit the rev limiter, pick it up. I think it might have been 6th, and then you would backshift to 5th and throw it into this right-hand sweeper. It was very top-endy. Anyway, we raced around the track. Schwantz was there, and he regaled us with stories of test riders who had died, and then this one guy who crashed and they couldn't find him, and he had flipped over this barrier and he drowned, and just he was really bolstering our confidence for testing at this track. It was not the safest place I'd ever ridden fast. And we also got a visit to the museum, and what was remarkable about that is, like, there's Kevin Schwantz's championship Suzuki from '93.
Yeah.
And I'm like, man, this is great. Well, check it out, though. We're walking through this museum, and there's all these old bikes, and it's as if they're not being touched. And I go up to Schwantz's GP winning bike, and there's like white corrosion coming out of the master cylinder on the brakes. It just seemed like, here's the museum, and we're going to forget about it. We're not really.
Yeah. Not a lot of polishing going on. Anyway, in '88, Suzuki decided, this hot kid in the States, let's get him. He had just won Daytona on the '88 bike, which had narrow power, Suzuki style. And it took him years to work up. Every year he would finish a bit higher in the championship. Finally, in '93, he was world champion. And you have to give him credit for being not only hardworking, but patient. The story of Suzuki is not a story of a lot of systematic scheduled breakthroughs, but rather the way they have advanced is like I described with Makoto Hase. He said, not enough power bandwidth. Let's try something else. jumping from 95 horsepower to 114, or deciding, let's build a light, simple motorcycle to counter these main battle tanks from the competition. The GSXR 750 was 100 pounds lighter than comparable bikes on the market. It was cooled by oil. It already had an oil system and an oil pump, so they decided to cool it with oil. And the bike was a huge success with people who wanted a good handling motorcycle that had strong performance. But Suzuki weren't going to break the bank in World Superbike. They took a Superbike championship in the U.S. With Schwantz, I think, and they weren't headliners. But the GSXR series was a money printing operation. It was a very successful seller. So that brings us to MotoGP. And MotoGP started out basically, I think somebody big in Japan said, everyone will operate a team in this new series. So, well, okay. And Suzuki elected to run. The displacement limit was 990 cc's. They were going to run a 60-degree V4. And then the next year it was 65 degrees. And then a couple of years after that, it was 75 degrees. Learn as you go, which is the way they had done it all along. Oh, at 60 degrees, there isn't enough room for the intake system. At 65 degrees, there's more room, but not enough. And they found all kinds of things that were of special interest, but it wasn't an easy process. And so after 2011, they decided to take a break. When I was finishing up my junior year at college, a lot of my friends were taking a year off because they just wanted a break. So at one point, I think it was 2004, I visited the Suzuki garage late one evening, and they were in there changing valve springs. If you want the top performance out of metal springs, you have to operate the wire at a tremendous surface stress. And the higher the surface stress, the shorter the life. So they basically, one day's running, necessary new springs. And I think they were the first to switch to pneumatic springs in MotoGP. But then they came back in 2015 with an inline four. Now, one of the big problems in MotoGP all along has been round riders versus pointed riders. The pointed rider, the point and shoot rider, brakes late, brakes very hard, early apex, get the bike turned at low speed, and Kenny Roberts says low risk, and then do what motorcycles do best, accelerate. The round people, taking the Great Circle route, which Barry Sheene did, are right at the edge of traction all the way around the corner. And this is Kenny's criticism of it. But it persists as a style. And the problem is that if you specialize, if you make your bike laterally flexible enough for corner speed so that it has reasonable grip at high lean angle on pavement that isn't perfectly smooth, then you have braking instability. The front end is tucking, it's wobbling around. Do you ever see brake hop? What fun. And it's very easy in the early days of MotoGP. Max Biaggi said, you feel it start to do this. And he said, before you know it, you're in the gravel. He said, it builds up quickly. So what Suzuki did was they said, okay, we want the side beams to be laterally flexible. So they're going to be thin. And that means that at the front, if brake bending force is applied to the steering head, the side beams are going to try to bow out. So what they did was to make two blades of carbon fiber, 70 millimeters wide, 5 millimeters thick, according to our friend Neil Spaulding, author of the book MotoGP Technology. Try to find a copy. These blades caused the steering head to be strongly braced against tucking under by being attached to the engine down low, and they had virtually zero lateral resistance, so that the designed in sort of high lean false suspension could work. And they developed this thing to the point that in 2020, this hastily run up inline four and its rider, Mir, were world champions. And I think that's a grand story because it's just like Suzuki. They come up with something that nobody else has thought of, and they maybe barely have the finance to back it. I mean, if you're going to the big table to play, presumably you have to buy chips. And they couldn't buy many. But they've been able to raise their hand and say, we're here. Remember that Honda hired an ad agency that said, you meet the nicest people on a Honda. Suzuki's agency told them to run this one. Suzuki are here. Are you excited? Let's go to the dealer and look at those. Suzuki are here. We thought it was funny then, and it's still funny. So, okay, their products had to sell on merit, and the GSXR certainly did. Will Suzuki be back in Grand Prix? I don't know. What?
No, I was thinking of the GSXR series and how they did all that club racing and they shoveled contingency out. And
oh, like, yeah.
Oh, man, look at that contingency. I got to race one of these Suzukis. And then everybody bought parts to race that bike, and it paid for the contingency. It's like,
and there was a whole core of riders who were contingency gypsies.
Yeah,
it was a great life.
Doug Poland, right? Wasn't Poland one of those guys? Yeah.
And Reverend Kevin Rentzel, I came around the corner at Daytona garage area, and there he was sitting in the open back of his van with a rack of carburetors off of his Suzuki, changing jets. And he had coffee, and I thought, what more does a person need? So I think this Suzuki story is an inspiring one because they have had the product that the market wanted after not really having a sterling start with the rotary and the, what do they call it? Not the tea kettle. The water buffalo. Yes. Motorcycles that made you say to yourself, what's it for?
Well, that was a very interesting period of time as several manufacturers were kind of searching for what they meant themselves to be.
Yamaha in the market. Yeah, with those strange things that they made.
Yeah, the four strokes were, they had the XS 650, which was a great big hit because it looked good, it sounded good, it was familiar, but it did all the Yamaha things that Triumphs were not, especially, as 1974 was rolling around. Great little motorcycle and, fun and reliable and terrible stock coils, but other than that, they were pretty darn good. And then they had RDs, which were a smash hit, but we also knew that was going to end.
It was going to end.
And Suzuki tried the rotary, and they had the Water Buffalo, the 750 two-stroke water cooled, pretty neat, but not not where motorcycles were going. I mean, Honda tried the CB 750 automatic in the late 70s, I think 78, 77. Put a torque converter on the 750.
Yeah.
Way to slow her down. So a lot of
Slush
mass,
box.
a lot of slush. Yep.
Yeah.
So interesting time. So Suzuki withdrew at the end of 2022, right? And
Yeah.
that was the end of it. There have apparently been a few rumors of Suzuki expressing interest in the next
The 2027, the
the
formula
27.
change. Yeah.
Yeah. So what is that? 850. So
850s. Yeah. And there are
and I
all
think
sorts of rules about this and that and the other thing. But it'll be a new game, which is always an opportunity for an outsider to play. Because right now, would you want to go up against Ducati?
seems that I would not.
Yeah.
As scrappy as we might think of ourselves, it's a real monolith.
We're scrappy.
Yeah,
But there's
Ducati's.
poor old Mark Marquez bumping along through the stones, taking hits to his lower unit. That's what they call the right angle drive on an outboard motor, the lower unit. It's always words have a way of leading us. But the poor man here, he's hammered. He can't get up. Finally, he gets up. He puts a good face on it. He says all those words that you'll find in my race report. Basically, I'm fine. Otherwise, I wouldn't be here talking to you. And later, he's saying, after Sunday's race, after the warm up, I was destroyed. I can't do this. Forget it. But then he said, adrenaline to the rescue. My favorite drug. Secreted by your own body.
Yeah.
And he goes out and wins. So that's a tough one to match. Yeah. But 2027 offers a fresh start, same for everyone. And who knows, there may be Suzuki in preparation. Let's listen for a moment and see if we can hear the dyno test article.
Would love to see it.
Yeah. So Grand Prix racing is a grand thing because, for example, while the four-stroke people were talking about the lost era and wringing their hands over the uncompetitiveness of the Triumph Trident after 1972, when 100 horsepower two-strokes tore their tires to shreds and little 350s won the race. What was actually happening was those two-strokes were a development team developing tires, chassis, and suspensions, which, when traditional four-strokes came to an end in 1982, those first-generation 1,000cc superbikes, the sit-ups that had to be completely re-engineered, when the Japanese built the second-generation superbike, it had all that two-stroke knowledge, chassis, suspension, and tires, off the shelf. What'll you have? And so the combination of those discoveries with improved four-stroke engines that no longer weighed 225 pounds. Give me a hand with this, will you? We'll put it in the frame. Yeah. Those fellows that were changing engines so rapidly in 88 and 89, RC30s, they had a lovely little tripod that fitted over the bike, and you could hoist the engine up with this little arrangement. And as soon as it lined up, your colleague would slip the bolts through. No need to lift that great lump. But
well, it sounds like their frames were a little bit better than the Triumphs and other stuff I've worked on, that you have to use a 3-foot lineup punch and then
really heave on it.
You got to get, that's the only way to get the bolt holes to line up. I was so naive when I pulled apart my Triumph.
Yeah.
That I thought, I couldn't get the bolts out. I'm like, what is, you pull it out and you squeak it out, and then you unscrew it, kind of buggering the threads as you're getting it out. And then you're like, okay, it's out. And then putting it back together, I just had no idea that that's how it was.
Yeah. Well, when we were with the dealership,
and
they said, of course, you'll want some of our fine Triumph 250 singles, which was a C15 BSA or some kind of dreadful thing. And each bike appeared and it had a warranty problem. And we had to replace head gaskets, which meant a lot of work. And some of them, the engines had to come out of the frame. And it was as though, well, it's just like Mark described. You had to beat the bejesus out of the bolts to get them out because the holes were so offset between the crankcase and the chassis. And you just wondered, what manufacturing process is this? Well, it was the manufacturing process of a corporation at sundown. It was sad. It happened. And Triumph now is made in Thailand, where there is a full suite of all the parts that are needed. Wheels, brakes, suspension, all these wonderful things. And they used to be present in England. England had the supply network. Naturally, it disappeared after 1970. Moved east. So we've had to, what do they call it? Pivot to East Asia.
Well, we'll pivot to the end of the show here. We appreciate you all listening. Suzuki's Grand Prix history is rich, and it's informed the rest of their product, informed the GSX-R 750.
For sure.
And of course, the Gamma, the road-going Gamma was a close cousin to the racing Gamma, and that's one of the things that made it so attractive to all of us back
yeah. Try to buy one now.
Back when we couldn't get one except through Canada, perhaps. Pretty wonderful stuff. So thanks for listening, folks. We appreciate it. We'll see you down in comments.